Hi, everyone. Welcome back to another episode of Leaning In and Speaking Out. My name is Michelle Lam, and I'm here with my co-host, Jackie Kirk. And we're having a conversation today from the perspective of science researchers, science educators, science professionals. And so we're talking about things like the philosophy of science, what that means, and we're going to dive into it. And I think I'll learn a lot because I'm not a science teacher, don't have a science background. I'm just going to ask all of us to just go around and introduce ourselves, and then I think we can dive right in. So do you want to go around this way? Ellen, are you okay to start us off?
Sure. Hi, everyone. I'm Ellen Watson. I'm an assistant professor in the Department of Curriculum and Pedagogy here at Brandon University, and my focus is on science education. I do some research in epistemology and philosophy of science and how it's integrated into classrooms.
Okay, and hello everyone. I'm Wei, and I'm a science teacher in a high school in Taiwan, and I also be a PhD student in the Institute of Education. I'm interested in philosophy of science, and past research is about indigenous science education, and I wanted to integrate science, philosophy of science, and history of science into the science education curriculums. Thank you.
Thank you. Jason, do you want to go ahead? I guess we're not really in a circle. Jason's joining by Zoom. Go ahead.
Good morning. My name is Jason Braun. I've been a science educator for 30 plus years, and I'm currently seconded to the province of Manitoba as part of the K-10 science curriculum renewal project. Thanks for having me.
Thanks for being here. And Greg.
Hi, I'm Greg Johnson. Been a science teacher for about 20 plus years. Spent the last 2 years working along with Jason under contract to renew and I guess rewrite the K-10 science curriculum for Manitoba. Thanks for having me.
Thanks for joining us. My name is Jackie Kirk, and I am a co-host of the podcast. And I am the chair of the grad program at Brandon University and a member of the Department of Leadership and Educational Administration. I'm excited about this conversation. I think it will be very interesting. And I bet I could just go ahead and ask the first question.
Yep.
So what does the philosophy of science mean to each of you? I think we'll give each of you a chance to answer that question. Ellen, do you want to start? We'll just go back in the same order, I think, and then break out from there. Sure. So the philosophy of science for me means thinking about science as more than content. It's a way of doing and a way of knowing in the world. So it encompasses things like how do we do science and how do we come to know things in science and how do we create new knowledge in science. Like I said, I tend to live in epistemology, which is part of philosophy. But I think it's all about thinking about science beyond facts that we might have learned in school.
Okay, for me, I think if we ask what is the science and how can we define the science, and we will talk about the philosophy of science. And I think philosophy of science, it means we wanted to find the principle of science, we wanted to metaphysics of the science. And if we can say, how we can say what is something is scientific. I think it's for me, it's a meaning of the philosophy of science. Yes.
Thanks, Wei.
So I'll just build on those statements. Similarly, I would agree that the philosophy of science deals with the foundations, the methods, and the implications of science. That is, as Ellen mentioned, less stress on the knowledge aspect and more of the doing, being of science. Looking at how science evolves within historical contexts and associated ethical issues associated with science. Exploring the cause of science, like what's the cause of phenomena, that would be an aspect of it, leading to explanations, theories, the implications of science in engineering and technology, and the resulting applications of those.
Thank you.
Yeah, and for me, I think it's understanding science's place as a way of knowing the world, finding out about the world, that has its own ground rules and criterion and epistemology that makes it different than, say, other ways of knowing the world. And kind of, I think, philosophy of science is finding out where the edges of science are, what is its proper domain and what is its improper domain, and when is, the word science being misused or misconstrued. And I think just trying to understand that kind of demarcation between science and non-science, and then once you kind of find where those edges are, exploring more about how science itself works. I think a lot of education in science is education in science and not really education about science. So it's that about science that I think I'm interested in.
That's really helpful for me because I feel like abstracting up a level and kind of looking down at a discipline is really helpful in understanding, like you said, the edges. And we've just lived through a pandemic. Mm-hmm. And so that makes me think about all the things that were scientific, like you said, all the things that were under that purview of this is science. Is there good science and bad science, or is there just science and non-science? And that makes me head into the second question, which is, why is it important that the philosophy of science be integrated into K-12 science education?
I think, honestly, as Greg was answering, that's what I was hearing is, if we want to teach people science for more than the purpose of being scientists, which we know not all of our students are going to be scientists, we need to teach about science as well as teach the science itself. We need students who can make informed decisions about climate change, about vaccinations, about lots of things in our world. And teaching about science, teaching the philosophy of science gets to that. It helps produce, knowledgeable citizens, which I think also fits into our Manitoba framework, our new framework, very well.
Okay, because in Taiwan, our science education in K-12 will usually focus on knowledge and practice skills of science, but just Alan says, not each student might be a scientist. So if our students we learn for this contest, they just can do experiments step by step. It will not. I think it's very important the student they can think in deep. They can have the think abilities in science because we need to let our students have some ability to face the real world questions like climate changes, or even in Taiwan we have a very bad air quality questions, and even a COVID. Students need some thinking abilities to face these questions. So I think it's there is not only based on the knowledge and skills, but I think it's very important it's founded by the philosophy of science. So I think philosophy of science is an important thing we need to teach our students in a K-12 educations. Mm-hmm. Yes.
Yes, I agree that it is a very important aspect in K-12 science that we, in a sense, enable students to enhance their conceptual understanding of just going beyond the facts, going beyond the memorization of what the different aspects of different fields of science are. And I think once you do that, you can help enhance the student's ability to critically think about what science is doing. That is, what methodologies are being employed, why are certain justifications made, and how to disseminate from information and disinformation, especially on social media. Enabling those skills is enhanced when you're delivering a curriculum with the philosophy of science in mind. without it, it becomes just, in essence, a notebook, and you're just reading words. This puts in a sense, the meaning of what science is and how the science process evolves and grows, and how do we know what we know when we know it, in a sense. So it's a very important aspect to go beyond, as I said, the facts and facts of science. Yeah.
Yeah, I've kind of thought about this a little bit, especially doing curriculum work. Thinking through my own experience in a science education, I think that the typical route is you do your K-12 education, and you get a little bit of a dose of science all the way through. But it's a pretty, I would say, unself-critical education. In other words, science is just sort of presented as a set of unquestionable facts. There might be a little bit of dabbling into where some of them might have come from. I think often you get this presentation of science as a progression towards better theories or better knowledge as time goes on. And I think even going into an undergrad science degree, there's very little discussion of some of the historical controversies that existed in science, and the ways in which certain theories come out on top of other theories. And I think by teaching science in kind of that uncritical way, it gives this idea, especially to people who don't continue on in science education. I mean, in Manitoba, mandatory science education currently ends at grade 10. So if you get a science education that basically presents it as a body of facts, and then you go out into the world and you see areas where maybe science isn't like weather, let's say weather prediction, for instance, you hear that old trope, like, Lisa, how can we predict global warming? Can't even predict the weather, 2 days down the road. And I think there's just, or you can predict the locations of planets, hundreds or thousands of years into the future, but you can't do this. And I think it throws into question, or it opens up areas for people with certain agendas, or who want to spread misinformation and disinformation, or just general misunderstandings of how science works, and it makes people, it puts them in a bit of a dissonance where they've learned up till grade 10 or even to the end of grade 12 that science are these unquestionable facts that kind of have it all empirically figured out. And I think without getting to the deeper philosophy of how science is done and how difficult it is in multivariate systems to actually predict things, like epidemiology is another example, that it's very difficult to exactly figure out where things are headed. I don't think that a typical science education puts into focus that kind of like questioning aspect of science, or the, again, kind of like what I alluded to a bit earlier, and I think we saw this during COVID too, where science, it didn't fail, it was going through its natural process, but to an outsider looking in, it seems like, oh, science is failing to do this, but failure is a built-in part of the way that science progresses, in my opinion. So I think, back to the original question, by presenting science as it really is, rather than a sort of idealized view that we often get in typical science education, I think will help a lot with the general public's understanding of the way that science works, and why it's so hard to predict the weather, for instance.
I think too, on that, Greg, also and everybody's kind of talked about this, taking that step back and thinking about science and what makes up science and how it works, also forces us to see science as a very specific way of thinking. And so it opens up to potentially integrating Indigenous ways of knowing into the classroom a bit more authentically, because we can see that they're working in knowledge systems. And so if students don't really have an understanding of science as, what it is, it can be very disingenuous when you try to bring in that Indigenous ways of knowing. But if you could talk about it as, this is how we know something in science, and this is how somebody else explains what we know in science. That's another benefit for including the philosophy.
Yeah, I totally agree, Ellen. I think, sorry, I didn't mean to, but just, you know, our school taught in the IB curriculum, and they have a theory of knowledge course, which I think is an excellent course that, you know, if you ever get a chance to take a course like that, and I think probably some undergrad philosophy courses are very similar, but just that idea of, you know, really thinking about like almost like Venn diagrams of here's the ring that's science, you know, that's all of what science encompasses. You know, here's a ring that's religion, here's a ring that's maybe mathematics and logic, and, you know, here's a ring that's indigenous knowledge, and there's intersections between those rings in certain places, and there's areas that, you know, they're dealing with different parts of the world. And I think we miss out on that a lot. Hey, in a typical education, you just learn about history in its bubble without seeing how it interacts with the rest of the knowledge systems that are out there.
Yeah.
So what I hear you calling for is a change in the way that we're teaching science and integrating science into the curriculum. What does that require for teachers? What do teachers need to do differently? What do they need to know to grow into that new place?
It's a good question. I'm going to pass it over to the ones who are in classrooms or very close to classrooms right now.
Well, I could take a swing. I think probably kind of as maybe alluded to, that zooming out and that understanding of various areas of knowledge isn't really part of a typical, you know, K to 12 education in Manitoba. I think, you know, people coming into science teaching generally followed that trajectory of, you know, K to 12 science education, and then an undergrad in science, and then likely an after degree in teaching. And, you know, if they chose to maybe take a philosophy course in there, then they might have a bit of a background in that. But if they didn't, if their electives didn't integrate some philosophy, it's very possible. And this is me, like I came out of education as a science teacher with a good training in science, but very little knowledge of anything else outside of science. And I think, you know, if you aren't exposed to it, how would you know, you know?
So I said I was going to pass it over, but I'm going to jump in here. Greg, you know, I've actually done a scan of universities across Canada looking at their science teacher education program. And what I found is very, very few. I think there was, you know, maybe 3 or 4 across Canada that require some sort of philosophy or history. Sorry, probably closer to 10, but most of them are in Quebec, interestingly enough. None of the prairie provinces require that philosophy before going in, with the exception of University of Alberta. So you're right, it's very rare that unless they chose to take that class, it's not something most of your science teachers will have. And they'll take 1, maybe 2 science methods courses in their programs. And, you know, that's if you have time. Everybody teaches the nature of science, but how much time will you get for it?
I have a feeling, and this is coming right out of the top of my head, but I have a feeling that it's connected to, and it's hard to tell which is first, the chicken or the egg, but connected to our understanding of science in our society and how we hold science so highly in our society. I think, you know, in some of your research, Wei, you talked about how elders in your Indigenous communities had important knowledge that we sort of pass by, right? We sort of say, oh, it's not worthy. And I think what I hear you talking about science is that it should be bigger than that. But we have completely bound our society in, if it doesn't have numbers or if it doesn't have evidence, then I can't trust it. And I wonder if, like, I don't know where that starts, but when we start to talk about the system and talk about how the education system is sort of falling down on not helping people to see a wider view of science, then we look at the university system And Greg, you were saying that the first year university science classes didn't get any further than that. I think it's really probably a reflection of our societal values as much as anything. And maybe we need to be thinking about how do we change that?
I think it's a very important thing to let our students they use the science knowledge or their skills into their real lives and to face the problem in their dailies. Because like Taiwan, our students they learn the science, they learn a very big number of knowledge, the skills for even the physics, the chemistry and biology and earth science. But when they face on like the weather prediction or the earthquake reports, they may not use they ever learn to explain or to understanding this report. They just use their directly feelings to say, "Oh, that's very nervous. That's very important. That's very serious." But they don't depend on some evidence or some data, and so I think to integrate the philosophy of science is we don't need to our students they become a scientist, but I think it's very important to let they can think in their daily life like the scientists for use some knowledge or their skills or their understanding to explain that.
This is like the chicken and egg. So you were saying like the worldview needs to change. And you're saying like the mechanism for making that change is like starting with the students and teaching them to think differently, right? So is it a top down or is it a bottom down?
Well, and so when you were talking, I was thinking that sort of takes us right back to what do teachers need to grow? Because I think most things in our society, when we try to change them, we start with education. And I wonder if disrupting some of the assumptions that teachers make about science, I wonder if that's the starting point. Thank you.
Podcast is done. No, just kidding. Well, I think that's our next question, actually, right? Like, how can it be integrated in your specific context? So as a post-secondary educator, you can do, right?
Yeah, I bring it into my classes and I talk about it. I find especially when I'm working with early year teachers who aren't necessarily as comfortable in science, when I say, "Oh, we're not worried about the facts of science. Of course, we need those to be correct, but let's talk about how it works and how the world works." A lot of students they're more comfortable with that, which is interesting because when you talk to the science specialists, the senior science teachers, they're like, "Well, but no, I have to teach the Newton's laws unit." And it's just a really different way of thinking. But as Greg pointed out, they're so schooled in science by that point that you almost need to help them take a step back.
I think philosophy of science is very strongly connected to the history of science. And in this way, I'm trying to start from some important scientific events in history and to give our students some context to think how the science development in the history. And then maybe go through how the scientists think at that time. They can let our students to understanding what is the difference between scientists and students their own. And through this design, it could be I think it's a long-term process to let our students to try to learn and try to use these thinking abilities to face the science issues. But I think based on the history of science, some events probably can make our students to think about the science, philosophy of science. And on the other ways, I wanted to let our students to try to search some advertisements or some in something in the social media, they try to check this is a good science or the bad science or even a pseudoscience. Yes, I think it's very important to let our students to know, is this a real science or even is a pseudoscience?
I remember you saying yesterday, Wei, in your talk that after doing this project with an Indigenous community, you had looked at your science textbook and it was all what you called Western science. And your question was, where's the Eastern science?
Yes.
And so I really like what you're saying about going back through the history of how did this come to be as what's considered and taught as science. I think that's a great way of like integrating history and science and would really help students be able to answer that question. How did this come to be in my textbook and what's missing?
Yes, because in our textbook, we also talk about Eastern traditional science, but it just to introduce for example, how to observe the stars and how to use the water power to make agriculture more easily. But I think it's in history of science of Eastern society, we have some point. We just have points. We have not a very complete process and context to explain and to develop a science theory. So I think it's a quite different from the Easterns and Westerns. Yes.
Yeah, and that's like what you were saying earlier about how artificial it can seem to just insert Indigenous knowledge into something without that broader perspective of whole system.
Well, and I think something else we'll see along with the philosophy of science is more of an integration of identity and identity as it's connected to science. PISA 2025 has released their call, or they've released their framework on what they want science to look like, or what they think good science thinkers do. And in there is identity and how students see themselves in science. And I think philosophy of science opens the door to get there.
I think in my opinion, you're almost talking about two different things in a sense. I think there's an education, like I alluded to before, like an education in science and an education about science are sort of two different things. I'm leery to go all in on we need to change the definition of science, or we need to add in to science things that maybe haven't always been there. That's not to say that that these other ways of knowing don't have value, but I think someone like Popper, for instance, really struggled with what belongs within that that Venn diagram ring of science, and what belongs in other areas, and where's that overlap. I think when you might feel some resistance to from kind of like the science establishment, to including Indigenous knowledge into science, I think you're kind of running up against that misunderstanding or that resistance, I think, to change that Western type of science. I mean, when I think it's something like 95% of people who are practicing scientists are doing R&D at various corporations, and it's very monetarily valuable, and you could argue that it's valuable to making science. You can look to science for some of the comforts that we have for our long lives, etc. And science is held in a very high regard because of those things. And at the same time, you can point to things like climate change or some of the major wealth inequalities, and look at how technologically and scientifically advanced areas of the world benefit while others of the world struggle. And I think it's maybe not so much about trying to change science itself, but better understanding that there should be more like, again, a zoom out and a better understanding of science as the human construct, as a human tool. Much like art or architecture, like it plays its role, or mathematics. You might change how you think about it or how you teach it, but actually going in and changing the definition of what those things are, to me, I that's where I kind of struggle a bit. Like, I feel like, again, a way of knowing the world is a scientific way. A different way of knowing the world is indigenous knowledge. A different way of knowing the world is a religious approach. A different way of knowing the world is mathematical or logical. And there's overlaps and intersections between all those things. So to me, it's bigger than it's bigger than just changing or expanding the definition of science to include more things. To me, it's more about keeping science within its proper place and not trying to make it cover everything. You run into problems when you start trying to call things science that maybe shouldn't be called science. You see this in education all the time. You put science in front of something and it's supposed to give it more weight. But I think, if you have good training and a good understanding, you can quickly see, well, we're really talking about pseudoscience. We're using some of the ideas and methods of science, but is it actually something that should be considered science? And I think more scholarship and research and education into where science belongs is important and would help a lot.
Yeah, I would build on that. I think one thing that needs to be reflected upon is what's the intent of the system? Like, what do we want our students leaving the system with? Do we want them to walk away with an encyclopedia of knowledge, or do we want them to walk away with the ability to take that information and apply it in multiple aspects that they would never have known that they would apply it before? I think it's important that that statement, that aspect, like what's the intent, like because when we look at jurisdictions across Canada, you have to reflect back to how did they develop their curricula. In a sense, was built on from the Pan-Canadian document, which was, if you look at it, it's intense. It's quite in depth and broad. There's a lot of information there. So when you throw that to the provinces, and the province says, like, hey, I guess we got to adopt this and then build it into their systems. And then it trickles down to the teachers, and teachers go, okay, it looks like there's a large amount of information that we have to share with our kids as part of my role in this occupation, and therefore it feeds into that. So if there's an opportunity to change the paradigm, to change the way of thinking, of moving away from a knowledge system, like, I'm not discounting that. I think it is important, but how do you apply that information and having students develop their competencies in science in ways that they'll use elsewhere, that they would have never thought they would be using before? Because, as mentioned before earlier in this podcast, was a lot of students do not progress into the upper grade sciences in this province. And so that's a challenge that we need to recognize and say, well, what can we do to improve that? Because as we saw during the pandemic, there's a lot of opinions out there that were based on misinformation. And so we need to enable students to have the skill set and the critical thinking aspect, and in terms of skills of what information is being sent to me and how can I discern that information? How can I look at that information in a way that I can go, well, you know what, that's not really accurate, when they throw these facts and figures out there, and be able to do their own investigation about what's out there and go make an informed decision about that. So I'm just going to go back to, like, what does the system want? Like, what's the, in a sense, the governments want with their students when they leave the system? I think that's important. And when that direction is given and teachers recognize that, they'll follow through. So if there's an opportunity to embed philosophy of science in their programming, not worry about day-to-day tasks, like every day I'm doing a new lesson because there's more information I have to share, but give teachers an opportunity to take that information and go, okay, well, yes, that information is there, but it's been developed in a way where I can start incorporating other aspects, like more inquiry, more I don't want to go back to the labs, but that hands-on skills, whereas opposed to you teach how you were taught, in a sense. And so if we break that model, in a sense, and adjust it where we enable teachers to deliver their program where students have an opportunity to have their voices in the classroom, I think will go a long ways, much beyond the science education system.
In my experience, teachers love talking about this stuff. They love talking about and thinking about, what's the intention of the system? Why am I teaching science? Why do I think science is important? And also, how do I view science? That step back of how do I think about science? How does the system? And lots of maybe I'm only talking to teachers that like this, but lots of teachers love talking about that stuff. So I think even having some of that space when they can start thinking about it from their perspective and how they feel and how they think about it, then when you engage them with things like curriculum documents, they can see it more in there, and they say, oh, okay, this is how this person's thinking about it, and this is how this person's thinking about it. So but teachers are so busy, like Jason said, they have so much on their plate that for us to go in and say, hey, we're going to talk about philosophy occasionally, lots of teachers would say, no, I need to plan my class. And they're totally right. I completely get it. But that is, if I had my dream wish, I think that would be something, we have these conversations.
So how do we get to them to share that with students? Is that going back and making sure that it goes into the curriculum? Is that making it a priority of the government? Is that, exciting them about talking about the philosophy of science? What is it? How do we get them to share that so that students come out more well-rounded in that area rather than facts-based?
Well, I do think it starts a little bit with curriculum. What is there space for in the curriculum, and what does it emphasize, and what does it highlight? So, our pilot curriculum, the Manitoba pilot curriculum, is running this year, and I think, spoiler alert, I guess, but like there will be a bit more of a forefronting of some of these ideas. Not that they aren't there currently. It's just, I would say maybe the way that they're presented, and Jason alluded to this, we have a lot of specific learning outcomes in our curriculum. So many that basically teachers are trying to hit a new topic almost every day. And you kind of, in that scenario, you sort of blow by or brusque over some of those other important underlying parts of that curriculum. And I think a little bit of that has to do with the way that the current curriculum is presented. It's a little bit older, it's document based. Some of that philosophy of science or nature of science stuff, you find in the GLOs, which are in an appendix, kind of separated out from the SLOs. So you can't really blame teachers for maybe missing the importance of that. So I think in the new version, we wanted to make sure, and I say we, but I mean our team, the group of people working on this, all the people that gave feedback, wanted to make sure that some of that stuff was more in the forefront. And I think when more awareness of what this renewed curriculum looks like, I think people will be happier or more aware, I guess, of some of these nature of science ideas.
I just want to touch on the idea that bringing in the philosophy of science, as we mentioned before, is an important aspect, and allowing teachers to take those risks and acknowledge that aspect and enable those teachers to take those risks and say, yeah, go for it. This is your classroom. We believe this is a direction that we want to go. Once teachers start hearing that, they'll welcome that. They'll bring it part of their class, and they'll seek out information on philosophy, because a lot of teachers, and Ellen, you can comment better on this, I guess, in early years and middle years there may not be as many teachers with a science background as Wei has in early years and middle years. And so in a sense, they're being thrust into these roles where they're going to feel uncomfortable. So how do we adjust that mindset so that they feel, okay, well, I've never taught science before, and I only have high school science as a background. But you say, well, no, here's a program, here's a curriculum that's written in a way that will enable you and welcome you to take those risks. And that part of it is delivering a curriculum that it's not as a notebook. I'd rather deliver a curriculum, and we can take a page from Indigenous elders. I think Wei may be able to comment on this better than I can, but where we tell it as a story, where students will grasp, will grab, will listen, and become much more engaged when the information is shared in that type of format, as opposed to this is step A, step B, you're sharing it as a story, and you're making it, how would you say, more experience the information as opposed to being told the information. And that involves, again, an opportunity to deliver the programs in environments outside of the classroom. And we've seen this work in a number of areas, and hopefully, as Greg alluded to, this draft will enable teachers and empower teachers to follow that.
I think something too is for teachers, if they're looking for an easy way to put this in, the research is really clear that students learn these aspects about philosophy of science when they're made explicit. So even for teachers to continue doing what they're doing, many of them, inquiry is very common in our classrooms now, especially in science classrooms, and making it explicit about what that's showcasing about the philosophy of science, or disrupting current systems. We hear all about the history of the atom, and every teacher I talk to when they talk about the history of science, they bring up the history of the atom model. And so, just by disrupting that and saying, what was happening at the time of that? Oh, look, why we have come to that, or even thinking about it as a model, right? Well, this doesn't necessarily represent reality. Like this is meant to showcase how things might work, and making those small things explicit are an easy way to put that in. But it does require quite a bit of knowledge and capability to step back and see those things that you're going to explain.
I wonder about when in Manitoba we shifted how we teach math, and how at the very beginning teachers were like, well, I don't know how to teach this way, right? And so I wonder if the kind of shifts that you're looking at could be parallel to that. And again, I'm speaking very far outside my field, so you can tell me if that's not a good comparison, but the idea of zooming out a level, having students understand the mathematical concepts as opposed to just memorizing the formulas. There's, I think, some parallels to what you're describing in how you'd like science to be approached in the classroom. You're nodding.
I am, and I could also foresee. I can see that happening potentially with the new document, but I can also see people standing up and saying, "Well, we need to teach science," because they have a very different view of what they think science is, which is what we saw with the math curriculum, right? Some people saying that this is what math is and this is what it's not. So I think, as Greg has alluded to, if we can make it clear we're trying to look at what science is and what's in that bubble and keep it in that bubble, as opposed to, trying to consume everything with science. Because we're not asking these teachers to be philosophy teachers. We're not asking them to be social studies teachers. We're asking them to teach science, but in a contextual way and looking at what science is.
I'll tell you, it's not easy writing curriculum, and you hear from many stakeholders and rights holders, and everybody has an opinion really on how science should be taught and what science should encompass. And you have the pull towards science is to create more scientists, or you have that other pull, which is, science is for everybody and everybody needs to understand it, and almost nobody becomes a scientist. So why are we, running a program of training scientists when almost nobody becomes a scientist? And is that program actually causing less people to want to be scientists? And it is a very challenging space to be in.
I can imagine that, yes. I've never experienced that, but I can imagine. Are there any other final thoughts on integrating the philosophy of science in classrooms? Any kind of last words?
I think it's I thought after that is a long-term process for our students to learn, to understanding philosophy and the nature of science. So I think could be too worried that can see the significant need effort in the short time. Because in Taiwan, we always wanted to see some efforts, some successful process in the short time. But I think in the educational process, we need to see the long terms and to see even 10 years, 20 years, how these students, when they graduate in the university, then into get a jobs, and how they think and how they changes the they changes the context of society. So I think we can think a short times achievement, and we need to see a long terms and to it might give them more time. It might be something different. We can see our students.
Thank you. Yeah, I agree. Any other last thoughts?
I just have one. I don't know who has the power to do such a thing, but I think that anyone who is going to be a teacher of any sort should be taking some sort of theory of knowledge philosophy course, maybe more specific to whatever area of study they're planning on going into teaching. But even for generalists, I think getting that understanding of which circle science is in and which circle all of the other areas of knowledge are in would be extremely helpful. A history of science course in there somewhere as well would be very valuable for people going out and teaching in the world, and not just training in science, but training about science. So, if BU's listening, let's get a philosophy course for every teacher candidate that's coming through, and maybe more specifically a philosophy of science course.
Greg, it's like I planted you in this conversation.
Right? I've heard her talk about this before.
But I love the idea of having, a theory of knowledge class for, obviously I would like to see one for science, but I think for everyone, I think that would be great in every science degree. You graduate with a degree in physics, I think having a philosophy of science would be an important background as well. If I can push my luck, but let's start with the teachers because I have a little more sway there.
Well, I thought the engineering degrees are evolving in a way where when they are working on an issue, they have to bring a more global perspective of it. So that's it kind of lends itself towards what our discussion is on today. I just would like to add on. I think to get philosophy of science having a greater impact in the classrooms and post-secondary institutes, there's a lot of stakeholders that need to be on board with this, and including the universities, post-secondary institutes. I get have offering courses, but there are other agents out there to help support teachers in incorporating the philosophy of science. If they don't have that education background, there are opportunities out there that I've noticed. For example, Let's Talk Science is a national organization which helps, which is it involves philosophy of science as part of their system. And same thing with the Perimeter Institute in Ontario. They just published a document on similar discussions that we've had right now on theory of knowledge. And so there are other venues where teachers can go explore. So what I'm getting at is it's not just up to post-secondary institutes to ensure this. They're part of the solution. That I think governments are part of the solution, and also other agencies that will help support teachers in their own professional development are part of the solution as well.
And just like one last thought too, I think when again this draft document starts getting seen or more widely distributed, and as we go into the renewed curriculum, I'm very hopeful that there'll be some renewed scholarship and sharing in workshops and so on, as Jason was mentioning, but that this curriculum will sort of help drive some of that to be brought into the forefront.
Mm-hmm. That's exciting to see that that's coming up in the curriculum. I think that's a good place for us to draw the podcast to a close. I'd like to thank all of the guests for coming in and sharing your knowledge with us today. And Michelle, thank you.
Yeah, I have nothing to add other than thanks. I learned a lot today and grateful to hear from all of you. And good luck with the new curriculum coming out. And we'll do what we can from our end. Thanks.
Thanks.
Thank you.
Thank you.
Thanks.
It's awesome.
Thank you.